Hello, friends of chemistry. Please have some sympathy for poor Martin stuck here with me.
Mom's lit jokes are not as hip as she thinks they are.
Anyway,
And
are we ready for
me.
15.8?
She thinks.
Hast thou read the module?
That's much better. Thank you. Now you're speaking like you're supposed to.
Hast thou prepared?
Assume that the following reaction has achieved equilibrium. CO2 gas plus H2 gas is in equilibrium with CO gas plus H2O gas. A. What will happen to the concentration of CO and H2 if extra H2O is added to the system?
Wait, the CO and the H2?
Yeah, what will happen to their concentration? More
if extra H2O
is added to the system.
Okay, so if extra H2O is added to the system, that will balance things towards the which side? The product side of the equation, right? So the product side of the equation is in the numerator part, right?
Yes.
So how will that affect the concentration of the CO?
It'll decrease the concentration.
Right, because it wants to keep that number the same, right? How about the H2?
That'll also decrease in concentration.
The H2 is on the other side of the equation from the H2O.
So it'll increase its concentration. Yeah, that sounds right.
So the CO will increase, and the H, wait a minute. Sorry, CO will decrease, and the H2 will increase. You ready for letter B?
Give me a second.
Mm-hmm.
Okay, ready.
Okay, read it for us.
Okay. What will happen to the concentration of CO2 and H2O if CO is removed from the system? Come on, everybody. Come see the oppression inherent in the system.
That's right. Fortunately, a platypus is controlling me, so I don't even notice. All right, so if CO is removed, we're taking it out. What will happen to the H2O in order to keep the numerator the same?
It will.
It will have to increase, right? Yeah. So the H2O will increase. The CO2 on the other side of the equation will have to decrease.
Yeah. Okay, what will happen to the concentration of CO and H2 if extra CO2 is added to the system?
If extra CO2?
Yeah.
Okay, where's the CO2? It's a product or reactant?
It's a product. I mean, reactant.
It's reactant. So if it's a reactant, okay, we add more of it. Now, where are the reactants? They're on the denominator, right? So they're what we're dividing by to get the K.
That will decrease the concentration of CO and increase the concentration of H2.
Wait a minute. So if there's, so look, I've got, this is going to be A, so it's going to be on the bottom, right?
Yeah.
So if this number is getting bigger, right? Let's imagine I have like, say, 20 and I'm dividing it by 4. What do I get?
Then you get 5.
Right, but now if I divide 20 by 5, what do I get?
4.
So to my number, when the denominator gets bigger, the numerator gets
Smaller.
The answer gets smaller. So if extra CO2 is added, I'm increasing my numerator.
So then it's going to be bigger.
So in order to keep the numerator, in order to keep the answer the same, I have to increase the numerator, right?
Yes.
So this, if the extra CO2 is added, the CO actually will increase, right?
Yep.
But in order to keep the denominator the same, the H2 actually has to decrease. Does that make sense?
Yeah.
Okay. So did you write?
Done.
Excuse me. Did you write it all down there in your handy?
You see all that written down there?
Dandy notebook. All right. Thank you for joining me, Martin. Will you come and flash something at the screen so that everybody can
You
see
want me
it?
to flash the screen?
No. Flash something up. Okay.
Careful not to
Can
get
you look a
blinded.
little? Thank you. So I didn't have to. We all thank you.